Welcome to a demo entitled The Dual Nature of Objects, where we explore some interesting behaviors of the CObject variable type in 4D. My name is Brent Raymond. I organize the 4D Method, 4D, and Wakanda user group. You can see more about the user group here at 4dmethod.com in the About page. But we meet on a regular basis to discuss 4D and Wakanda topics and share ideas about what can be done with 4D and Wakanda. So, the dual nature of objects. Let's take a look. This is a demo database that I put together. It can be accessed on my GitHub site, which is also linked on 4dmethod.com. So, we're going to take a look at CObjects, and specifically we'll be using the OBSet command pretty regularly. You can see the documentation by going to this web page here or by selecting the command saying go to definition. It will open it again. But basically you give this command an object and a property name and set a value. So it's quite easy, and you can chain a bunch of different property values together to set them all in one call to this command. Namely, in the documentation, it says if you pass a language object, the command uses the object reference and not a copy. That is an interesting aspect to objects. So let's get into the code so that we can talk more about the duality of object variables. So, and here we just have some variable declarations, nothing to see there so much. But let's go ahead and build an object with the following loop. We're just going to loop from 1 to 2. We're going to set attributes of the object in this loop. We're going to set the attribute of an object variable and then append it to an array of objects. Okay, so we'll just put a stop there, and so you can see what's going on. Sorry, just have to resize this. Whoa. Used to being on a bigger monitor. So yeah, so let's take a look at the object that we're building. In this case, we've got the object record variable with the value attribute of 1, and then we have an array of objects here where we're building, we're appending these values in the record object. Okay, so we'll step through, and I've set the value for record once, and I'll go through and set it again. Note in this example, keep an eye on not only the values in the record object, but also the value in the array element, the first array element that we appended here. When you set it, it's not only updating the record object, but it's also updating the first element in the array. And then we append another one. So essentially, the array contains references, two references to the same object variable. So that's an important thing to note, because this is a common construct in programming languages where you create a value and you append it to an array. But it's not the most obvious thing that you would think of for this kind of a construct. In fact, if you were just adding the values 2, 1, and 2 to a long integer array, well, it wouldn't act like this. In this case, it's acting more like a pointer array. A pointer array, and you're adding 2 pointers to the same object variable. So let's take a look at another approach to the same kind of task of building an array of objects. So we're going to clear out our record and data. In this case, we're going to use the object copy command, which copies the dereferenced version of the object to the array in this command here. So we'll set the record to value 1. We'll append that dereferenced object to the array. Come through and we'll set the second object to value 2, and we'll append that to the array. Now you have two distinct objects listed in the array, and that's an important thing to note. It has a clearly different result than the first code that we went through. Okay, so we did it. We made an array of individual object variables. Is that the only way to do that? No, I think there's another way that makes sense to me anyways, but it won't make sense in all instances where you want to do such a thing. Instead of using object copy, you can just clear the variable each time you start the loop, which clears the reference to the previous object variable. So we clear it, we set the value, and then we append it to the array. Okay, that all looks the same as the first time around. We clear it. Now the reference is broken to the first array element. Then you set the variable again, and you append it to the array. And now you have the same thing that you get with object copy, except without having to copy it and have that data transfer, the memory transfer within the code. Not that there's a cost, there's just different ways of doing things like this being one of them. For this construct, this seems clearer to me without having to copy things around. But anyways, we're just talking about the sort of behavior and properties of these objects, because they act like a native variable, like a long int or a text sometimes, and other times they act like a pointer. And it's important to know which way that they're acting depending on how you want to use it. Again, I'm not saying there's a right and a wrong way. Just saying there's different uses that we haven't seen before with our previous variable types. So, what is the risk of doing it this way? One of the risks, in this case, again, manageable, but if you access the record variable again later in code, if this isn't the extent of your usage of this variable, you can still unwittingly change the values in the array. Oops, didn't mean to do that. Instead, you can clear the variable immediately after the loop and then set it, and it won't affect the array, as you can see here. Okay, now that much is clear. There's been a lot of conversation about these objects, but there's some other interesting things that you can look at. What about using objects as a parameter? So you're passing in an object parameter to a method. So let's step into the method. First time in, we're going to look at storing the parameter into a local variable, which is something at least I tend to do. That way I can give it a very descriptive variable name. Well, this isn't an example of that, but it's descriptive enough for our purposes here. And we're going to set the value, we're going to change the value of this local, what seems to be a local variable, to 3000. Okay, great. Well, we did something to that seemingly local variable. And when we step out, if we look at that O record, oh no, it actually has a value of 3,000 now. So if you watch closely, and maybe I'll just delete some of this stuff. The value was 2,000 and it became 3,000. So let's just, so that it's clear, let's look at that one more time. So 2,000, we step in and we set it. It's acting like a pointer. It's acting like a reference to the input local variable from the previous method, from the calling method. So point being, the method that you're using this object reference in can affect the local variable in the calling method. Okay, so maybe that's interesting. That is interesting. But maybe what you want to do instead is to use the object copy command if you want to ensure the input object variable does not get changed, does not change anything outside of the scope of this particular method. So let's go ahead and use a copy instead, and we're setting the parameter 1 to 4,000. Again, the local variable from the other method seems to be undefined here, except for the fact that it can be accessed. Again, the reference was broken when you did object copy and you worked on a copy of that particular object variable. So this is something to watch out for, or perhaps even leverage, as we'll take a look at here in our next example. What about using a single parameter, single object parameter for both the input and the output for a method? That is something new in the world of 4D, I would think. So we're going to create an input object, set the value to 2,000. We're going to set the input attribute of the parameters object to the input object itself. So let's just take a look at this. All right. So here we go. So now our parameters object has an input object with a value of 2,000. Then we're calling a method and giving it the parameters object. Come in, we use it directly. We don't use object copy. Well, we can use object copy. In this case, we're using the input safely, but we're operating on parameter 1. So we get the value from the input, and then we create an output object and set its value to 2 times the input value, and then we append that to, we set that in the passed in object reference. The object that we passed in, which is a local variable to the calling method, now has the input value of 2,000 and the output result value of 4,000. So that is something that you can leverage now. There's a development strategy certainly that could use that, even though it's a bit risky to modify input parameters to a method. Just kind of in my own coding, I steer away from such things, but it can have its advantages in this sort of a setup. Okay, moving on. Dealing with records. All right. So we also have object field types. Okay, so let's build our object. Let's do it the same way we did the first time around, where we have two elements in the array that are actually the same reference to this object record this record object here. I know hearing object so many times is probably making your head spin, but stick with me, please. So they both have the value of 2 because the second time around, just another reference to the same object, which we set updated the value to the number 2, which is the index of the loop. So we have just 2 references here. Right. So great. We've already seen that. Thanks, Brent. We're going to look at pushing this array to a table that has an object field. Simple table, p key, and object field. So now we should have 2 records, and we do. So we're going to select the first record, has the value of 2. We're going to update the value to the value 500. Okay, we're going to save it. And then we're going to go to the next record. Now, if we were to do that in the array, both of the array elements would get updated at the same time because they are just pointers. They're just references to the same object variable. However, once you push this array to records, they get split and they're handled uniquely. They're different pointed memory values once they're pushed into records. Seems obvious, perhaps, once you've gone through the other exercises. However, it's just important to make note of these things now. So the second record still has a value of 2, even though we set the first record to the value of 500. Okay. And finally, what about using field objects as a parameter to a method, as we did above, instead of using variables? So you can pass in a field object. So in this case, the field object, and I'll just clean up here. Field object has a value of 2, and we're going to pass it into this method here. And again, if you set it to 3000, it's actually operating on the pointed field value, even though it would appear that we're just passing in an object that is a value alone, but is actually a pointer to the field object. And again, if we were to do the same thing and pass in the field, except operate on a copy of that field, it doesn't update the field value. So anyways, that's all I've got for this demo, but it's just there's some interesting properties of these new C objects, and I think that we'll find some new ways to use them and find some interesting new programming approaches and constructs to take advantage of the dual nature of these object variables. Thanks a lot, and come see us at 4D Method. We'll see you in the next demo and the next meeting. Thanks. Bye.